Hi, this is Rick for EDU Mobile. Now we're going to talk about controls in Android. All controls in an Android application on the layout, or if we create them ourselves, these are all subclasses of View or one of View's subclasses. Controls can either act what we call actively or passively. Active controls are those that respond to user input in some way. Passive controls just display information. So now if we think about it, we could have a button that we are displaying some information in the form of that button's text, and then it's active because it responds to a user touch event or a click. The button, in this case, is acting both actively and passively. Usually controls act in one way or another, but you need to be aware that there is an and/or kind of relationship here. A control could be both active and passive. Another example, we could have a text view, which is simply displaying information, but we could make that text view clickable and have the user tap on that text view if we wanted to. And when the user tapped on it, if we handled that tap event or touch event, then that control would be, at that point, an active control. Again, normally text views are passive. We just display text in them, but they can be made active if we really want to do that. Now, we can either place a control in the layout XML file, as we have already started to see, or we can add a control in code. And, of course, we can handle these events. We can handle active controls events, I should say, whether they are placed in an XML file or the control is dynamically added in code. So all controls have attributes. We've seen these attributes in the layout XML file, and in addition to the layout metrics where we have, for example, match parent or wrap content for laying out the horizontal and vertical sizing of the control. We also have some important other attributes that have to do with controls' ability to function as controls. And some of these are, for example, Android text. The text, which is really a char sequence, it's an array of character types for the control. Android clickable allows you to say true or false. Is this going to function at this point as an active control, even for controls that are not normally clickable? So this is how you would set up a text view, for example, to be interactive. Android ID, perhaps the most important thing here, is going to be the unique ID of the control, and we're going to talk quite a bit about that in the next slide. And then Android onClick, you can set this up for click events with the name of the method that will handle those click events or basic touches. Android does call these clicks, even though on most devices we're not dealing with a mouse, we're not dealing with an actual click, we're dealing with a tap or touch on the screen. It is called the onClick handler, and it is the attribute Android onClick that we give the name of the method that's going to handle that thing. So just be aware that Android does call these clicks. So let's talk about this Android ID thing. Every control that we need to access in code, passively mostly, but sometimes also actively. Basically, if we are going to change something about that control, every control we need to access in the code must have a unique ID assigned to it. This is a 32-bit integer value, and it is placed for us in r.java. Once again, probably the last reminder, but please remember, do not ever edit this file. So here in the first bullet point, I have an example of setting an Android ID in the layout XML. And we use the @ plus. @ plus means create a new ID. And then here we've called it my text view. In code, we find these controls by using the find view by ID, and then we pass it the ID. Now, do we actually need to know the integer? Never. All we need to know is the identifier for the ID. In this case, we would just pass it r.id.myTextView because these IDs live as integers in r.java. Now, findViewById returns not the specific type of the control we're looking at, it returns a view. And so if we need that specific type, and not just as a view, which is overwhelmingly the case, we need to cast the return value of findViewById to the actual type of the control that we're looking at. So for example, in our layout XML, let's assume we have a text view, and it has a bunch of other attributes, but we're looking at the Android ID attribute in specific right here. And we have ID'd this, given it the name TextView1. Now, TextView1 will be written into r.java, and it will be given an actual numeric ID, a 32-bit integer ID. We don't care what that number is. Under the hood is the only place where that actual identity of that integer value is important. So in code, we can find it. We have created a TextView1, we have instantiated a text view called TV1, and assigned it the return value of findViewById with RID.TextView1, in other words, the ID we set up in the layout XML file, and we have cast that as a text view. Now, we can do a couple of things here. In fact, we can do a lot of things. Any method that a text view has, we can apply to the new TV1 object. So we could get the text that's existing in that text view using TV1.getText, which would give us a char sequence. If we wanted to assign that char sequence to a string, we then call toString on that. So this is an important pattern to recognize as getting a string called the text, or whatever we want to call that string, using the TextView.getText method .toString to cast it as a string. We could also set the text, TV1.setText, and then pass it in a string or a char sequence. Hello world, in this case, would set the text in that control. And that's really all we need to do. So for passive controls, this is the approach that we use. Now, a passive control can simply be dealt with using that kind of approach. But an active control will require your app to listen for events. Events are implemented in the view class as interfaces, and there is one interface for each event. And the events that exist are on click, on long click, on create context menu, which happens when a context menu is being created as a result of a long click, on focus change meaning when the focus changes either to or from this control or this view. On key is called when a key is pressed, and there are methods to find out what key was pressed. And then on touch is called on any event or called when any event qualifying as a touch or gesture event inside the boundaries of that particular view that we're dealing with happens. And once again, these listeners are all interfaces of view. Now, there is one special case in which you can actually deal with an event in a very simple way, and that is on click. For buttons and other controls for which you want to intercept this simple on-click event, you can create a method, and the method has a public void signature, public void button click, we're calling it here, and then we pass in the view. The view being the view that was just clicked. In other words, the control that was just clicked. And that method, we can do anything we want. We can deal with that click event. And then we can simply assign the Android onClick attribute in the layout XML for that control. And when that control is clicked, tapped, touched simply, then that method will be fired. This approach is only valid, and we've already seen this approach. It's the very simple way to handle click events. It is, however, only valid for on-click, for click events only. So keep that in mind. So what do we do for all these other events? Well, for other events, we must register, and we can also do this for on-click as well. But for most of these events, we must register an event listener on the view that we're dealing with. So, what do we mean by saying we must register an event listener? Well, an event listener, remember, is implemented as an interface of a view. So in our activity, we would set it up this way. We create an anonymous event listener. So first, we set up a private on-click listener, and here I've called it M long click listener. We're listening for a long click here, and then we use the constructor of a on-click listener, the default no-arg constructor. But then inside the block, we actually set up the method. So public void on long click view. This is similar to the on click method that we just looked at. And then here we would do something when the view receives a long click. So notice the blocking. We set up an on click listener. We make it private to the class. And then we set up a new on-click listener, and then we define it inside that block. In onCreate, or wherever we want to do so, we can bind this on-click listener, in this case, this on-long-click listener, to a particular control. So that is called registering it. And to do that, for the control, we first need to get it by its ID, and then we use set. And here, I made a mistake. This should be set on long click listener and pass it the identifier for our anonymous event listener. Very good. So we're going to look at a couple of demos that show both approaches to event handling. Thank you very much.